So it's nice to visit winter once again here in Salt Lake City, and thank you very much for the warm welcome here. I know that James Kirkland has been trying to get me up here to give a lecture on ancient landscapes for over a year now since the book came out, and it just worked out fortuitously with the Grand Canyon Trust and the other organizers to come up here and give this lecture. So what we're going to do tonight is we're going to take a trip a long ways back on a very beautiful piece of earth. And your mind is probably going to get stretched a little bit because we're going to have to imagine what this area looked like millions and millions of years ago. And I'm going to explain to you how geologists know that these landscapes actually existed in the places they did. And even if you are geophobic, I think you'll be able to learn something tonight about this beautiful place called the Colorado Plateau. And before I get started, I'd just like to echo what Colleen said to start out, is that the Grand Canyon Trust is an organization that works very, very hard to make sure that these landscapes that we enjoy today will stay protected in a way that our children and grandchildren can also enjoy them in the future. And even though you think that the national park set many of these landscapes aside, there's so many intervening areas that need protection, and also the air quality in these national parks is something that doesn't stop right at the park boundary. So the Trust headquarters in Flagstaff are located about half a mile from my home. I have many friends that work there, and I believe very strongly in the mission of the Grand Canyon Trust and these other organizations. Now, how many of you have traveled or love to travel to the Colorado Plateau? Probably you wouldn't be here. You'd probably be at that other Rocky talk tonight. Your ex-mayor is talking downtown. So instead of going to see Rocky, you've come here to learn about rocks. We're going to be centered on the Colorado Plateau, a very unique piece of real estate on planet Earth. And as Colleen mentioned to you, I've been fortunate to travel to almost 80 countries, and I'm looking for a place that approximates the Colorado Plateau, and I haven't yet found one. Landscapes like this, where you see these petrified sand dunes from the Vermilion Cliffs National Monument, record a time when our area was like a vast Sahara Desert. And in Canyonlands National Park, there are also fantastic layers of strata. And that's really what the focus of the talk is tonight. It's about strata and the record of Earth history that strata records. And of course, when we talk about strata, really the best place in the world to think about would be the Grand Canyon. And for those of you that may not be formally trained in geology, just realize that every single horizon you see in the rocks right there used to be the surface of the Earth. And the history of our planet is contained in this strata. And the Colorado Plateau has a fantastic section of rocks that helps us to interpret what the environments were in the past. So some of you may be wondering, what is the Colorado Plateau and why do we have it? The answer to that is that if our country had been established with states that were defined geographically, we would have 26 states rather than 50 states. And they would be states like Appalachia, the Adirondack Plateau, the Great Plains, the Columbia Plateau, and one of them would be the Colorado Plateau. And the Colorado Plateau is defined as an arid region in western North America that has colorful, flat-lying sedimentary rocks. And it's these flat-lying sedimentary rocks that contain this record. All of these rocks are exposed in canyons and mesas that have been carved by large rivers and their tributaries. And it's kind of unusual to think of a landscape that is arid but has large rivers flowing through it. I can only think of really two other places, and that would be Egypt's Nile River, and in Iraq they have the Tigris and the Euphrates. But the difference between those places and the Colorado Plateau is those areas are still close to sea level, and that strata has not been uplifted to a position where the rivers can chisel their way down and expose all this strata. So you might have an area that has colorful flat-lying strata, but more than likely it probably hasn't been uplifted. And if you're wondering about the confines of the Colorado Plateau, it's about 130,000 square miles. And generally you can find it in this gold-colored area. It's surrounded by two other provinces known as the Rocky Mountains. Everybody's heard of them. And the Basin and Range. Not too many people may have heard of the Basin and Range. But this is the plateau. It's essentially centered on the Four Corners area. And Utah and Arizona have most of the territory of the Colorado Plateau, and there's smaller amounts in the state of Colorado and in New Mexico. And sometimes this name is confusing to people, excuse me, because they think that it should be in the state of Colorado. And of course it's not, only 12% is. So this is the great stack of strata that is found on the Colorado Plateau. And it's about 3 miles thick. And right here at the bottom is the very bottom of the Grand Canyon. That's where Phantom Ranch is located. And you climb 3 miles through all of this strata, and you eventually get to the top at Bryce Canyon. Now, you never see all of this strata in one place. You can only see a very small part of it in any one place. And here's the Grand Canyon. You can see the limits of the Grand Canyon strata right there. And as Colleen mentioned, I'm a trail guide in the Grand Canyon. And when we're hiking out from Phantom Ranch and we get to the very top after hiking 9.5 miles, I'm so glad that I live in this day and age and I don't have to hike this extra 2 miles of strata going to the top. This stuff has already been eroded off of the top of the Grand Canyon. And we got here too late to see all of the wonderful landscapes when this strata was being taken off of the Grand Canyon area. If you go to Zion National Park, that's the section of the strata you see right there. And what that means that when you're on the floor of Zion Canyon, all of this strata in the Grand Canyon is still below you and not yet exposed to erosion. At Arches National Park, there's even a smaller section, and that's a beautiful place to visit. Just north of there is the Book Cliffs, and a lot of the coal that comes from the area around Price and Castledale is from these rocks right here, and these are the rocks that James Kirkland likes to study. And finally, at the very top, Bryce Canyon National Park, sitting on top of this stack of sedimentary rock. And just a very small bit of the stack is exposed at Bryce Canyon. And that means the next time you go to Bryce, think about it when you're standing on the edge right there. All of this is still in the subsurface and waiting to be exposed to erosion. So since you got here too late to see this strata at Grand Canyon, you got here too early to see all of this exposed at Bryce Canyon. So the Colorado Plateau has a very bright future indeed, because as erosion digs down deeper into these layers, there's going to be more and more of the landscape to see. Now, sometimes people ask, why is this area so rich in sedimentary rock? And the reason is that for about 400 million years, this area was very close to sea level and the crust was slowly subsiding. And when the crust subsides along a shoreline, it creates the space where sediment can be preserved. And it's called accommodation space. And so as this crust goes down here, all the sediment that is brought off of the edge of a continent has more and more room to accumulate. This is happening right now in the Gulf of Mexico where New Orleans is located. And there's a gigantic stack of sediment that's piling up at the mouth of the Mississippi River. And believe it or not, that's what the Colorado Plateau used to look like millions of years ago. It was as flat and featureless as New Orleans is today. So the important thing to remember as we look at these maps is that sedimentary rocks record the environments in which they were deposited. And no human being knew this prior to a few hundred years ago. When humans walked on the earth in the old days, they thought the landscape that you see today is the landscape that was always there. But geologists figured out, mostly in the 18th century, that these layers of strata contained a record of Earth history, and since that time we've been busy interpreting it. Now, one of the things that geologists use to do this is to look at modern deposits. And this is one of the most recent deposits I can think of. This is from Hurricane Katrina. And if nobody had ever been to see Hurricane Katrina, we still would know the age of this deposit right here, because this is a 2001 Crown Victoria. And it's buried in that deposit. So that means that that deposit had to come after that time. The other thing that geologists do is they look at the way that all of this strata here is layered or architecturally designed inside there, and that gives the clues for the environment in which it was deposited. And since people saw this deposit being laid down, when you find something like this in a lithified deposit that could be hundreds of millions of years old, you could make the interpretation that maybe there were hurricanes in the past that somehow left these flood deposits behind. And so really that's all geology is observing the modern world, the landscape that we live in, and applying that to deposits that were laid down in the past. And it's true that there's no deposit from the past that was laid down in an environment we don't have today. What we have today is what we had in the past. Deltas, beaches, sand dunes, shallow marine conditions, deep marine. Everything we have today is something that's from the past. So we're going to take a tour right now of the Colorado Plateau, and we're going to start with the very oldest rocks, as geologists usually do. Excuse me, I picked up something on the plane coming in today. And this is the bottom of the Grand Canyon here, Phantom Ranch. How many people have been to Phantom Ranch? Okay, about a third of you. I worked there for 3 years as a park ranger, and that's how I got all these rocks in my head. These are the oldest rocks on the Colorado Plateau. They're 1,750 million years old. And they're also exposed near Moab in Westwater Canyon. And you can see these dark rocks down here along the Colorado River. They're all part of the same package, which we generally call the Vishnu Schist. And this is the first paleogeographic map I'm going to share with you tonight. And what you're going to see on all of these maps is the very eastern corner of California, all of eastern Nevada, southern Wyoming, Utah, Colorado, New Mexico, and Arizona. And based on studies of the Vishnu Schist, this is what we think the landscape looked like 1,750 million years ago. And on all these maps, I'm going to put a red dot right there, and that red dot represents the location of this auditorium on all of these maps. I didn't want you to get lost. Sometimes the lines don't show up as well. So when we look at these maps, you're going to see a red dot right there, and that's going to be the Eccles Auditorium here, just so you can orient yourself. And what we had at this time was a series of islands, just like we have in Japan and Indonesia today. And these islands were drifting towards the northwest and eventually colliding with the southern edge of North America. And this was the collision event that created this schist rock, which formed 13 miles down in the earth. And there were these ancient mountains located in Utah and Colorado, and these volcanic islands came in from the southeast and collided with North America. And by necessity, I'm going to leave out many millions of years. We don't want to be here until 1 o'clock in the morning. And we're going to jump ahead now to the next layer that sits on top of the crystalline rocks. This again is from the bottom of the Grand Canyon. We don't have many places on the plateau where these oldest rocks are exposed, but if you look at this brown sandstone here, it sits right on top of those crystalline rocks right there and is known as the Tapeats Sandstone. Although up here in Utah, they also call it the Lador Sandstone after Lador Canyon. And this represents a beach environment that was present in the American Southwest about 525 million years ago. And again, on these maps, you can see the state lines and the county lines, so you can very easily orient yourself for any position in the Southwest at this time. And it was along this shoreline right here that these brown sands accumulated on this beach. And beginning about 530 million years ago, the shoreline was right here in Las Vegas. And through time, that ocean crept its way farther and farther to the east. It took about 30 million years to get to the New Mexico state line. And leaving behind it in its wake was this package of brown sandstone. Now I should tell you, these maps were created by my co-author, who is also a former professor of mine, Dr. Ron Blakey. And about 31 years ago, I took one of my first geology classes from Dr. Blakey, and he went on to develop these maps, and he's become well known for them. He's also made global projections for where this auditorium was all these many millions of years ago. And here is our home continent of North America. And one of the things I want to point out to you, this shoreline right here is the one that I was just showing you in a close-up view. that shoreline used to be oriented towards the north. Our continent used to be rotated around 90 degrees clockwise back 525 million years ago. And since that time, it has drifted north and drifted counterclockwise to give us the continent we have today. And these are other pieces of Earth's continents back at this time, 525 million years ago. Right in the middle of the Grand Canyon is an oceanic layer, a shallow marine limestone called the Redwall Limestone. It's really a barrier to travel for people who hike in the Grand Canyon because it's a 500-foot sheer cliff. But the story that the Redwall tells is very interesting as well, because this is one of the most extensive shallow marine environments that we have a record for in all of Earth history. And there was just a tiny little peninsula here in New Mexico, and the rest of the Colorado Plateau in the American Southwest was a shallow marine environment. Now, people sometimes think that if a limestone is thicker, that maybe the ocean was deeper, and that is not the case. The thickness of limestone has to do more with how much the crust was subsiding and how much life was in the ocean to provide the calcium for these limestones. We usually do not get limestone in deep water because critters can't grow in deep water. The photic zone, where most animal life lives in the ocean, only goes down about 200 feet. So when we see these ancient limestones in the Southwest, we're looking at oceans that are 200 feet deep or less, but they happen to last for a long time. So going on up towards the top of the stack, we have rocks from a time period known as the Pennsylvanian, and in the San Juan River canyons in the southeast part of the state, we have rock units known as the Hermosa Group. Many of you have probably floated the San Juan River. You can see the rafts there on one of the shorelines. This is a fantastic outcropping of rock that just about 15 miles to the east is 5,000 feet below the surface. And the rock layers are actually warped that much that this layer right here is almost a mile deep, just 15 miles to the east, and still contains oil. And one of the most interesting things to me is that you can go to this dry desert environment on the San Juan River, and yet it's the same rocks you see at the Hermosa Cliffs north of Durango. Now, I will admit that the modern environment of these two outcrops is totally different. These have aspen trees growing on it and spruce trees, but because of the way that the strata are warped across the landscape, a single layer can be found at various elevations. And these are one and the same deposits located about 50 miles from one another. This records a time in Earth history when there was great glaciation in the southern hemisphere. And here we see the American Southwest at about 308 million years ago. That's how refined some of these dating techniques are getting with geologists. We can say 308 rather than 310, and that's more of a correct number. But this shows a time 308 million years ago when the glaciers in the southern hemisphere had receded, and all of that ice that was tied up on land came as meltwater and flooded many areas in ancient North America. This next map I'm going to show you is when the glaciers expanded and the water ran off the land. So if we go back and forth there it is where the glaciers have receded and the water is in the ocean basins, and there it is right there where it has advanced and now sea level has dropped. These orange areas right here are meant to represent wind-blown dunes, and you're going to see many of these in the projections that I'm going to show you tonight, because a lot of the rock record on the plateau involves Sahara-like deserts on the landscape. And then to finish out this one time period, it's just really one of the most incredible sections of rock known anywhere on planet Earth. It involves a time period known as the Permian. In Canyonlands National Park and the area around Moab is probably one of the best places to see these rocks. And this is from the Needles District in Canyonlands National Park. Just to the east is a layer on top of that known as the Cutler Formation. Maybe you've been to the Fisher Towers on Highway 128 east of Moab. This is one of my favorite formations, and I'll tell you why in a moment. And then there's also the Vishnu Sandstone, which sits on top there in Monument Valley, deposited in a Sahara-like desert. And this unusual rock unit known as the White Rim Sandstone. You can see this white rim right along the Green River in Canyonlands National Park. And just coincidentally in this view here, you can see where the Green River used to flow in this loop right here. And that's now a cutoff meander that has been abandoned by the Green River. But these 4 packages of rocks highlight a time during the Permian when there was an ancient mountain range located in Colorado and eastern Utah. And I'm going to show you a map for each of these 4 formations. This is first for the Cedar Mesa Sandstone. And notice this mountain range up here. This mountain range is called the Ancestral Rocky Mountains. Geologists or human beings never saw the Ancestral Rocky Mountains. Look how long ago they were. MA, by the way, is an abbreviation for mega annum, and it means millions of years ago. 287 millions of years ago, this mountain range popped up, and nobody ever saw the mountain range. But the reason that we know it was there is because of the sediments that washed out of it. And those sediments are things like the Cutler Formation. And here you see the Ancestral Rockies, and you might be able to pick out that there's these rivers that are coming out of the Ancestral Rockies, and they're washing out debris across the ancient plain. Those are the formations you see at the Fisher Towers. And the next time you go there, if you look at the rocks really closely, you're going to see pieces of granite and schist that are about the size of your fist right in that red sandstone. And these are thought to be the alluvial fans that were present at the foot of the Ancestral Rockies, which, by the way, were completely planed off by erosion at 165 million years ago. We never even got close to seeing this mountain range, yet we know it was there because of these deposits. The Deshay Sandstone, obviously named after Canyon Deshay. That sandstone is very well exposed in that canyon, and it also makes up the tops of the monuments in Monument Valley. You can see that fringing this shallow seaway right here are a series of dunes, and there's where Monument Valley is located, and there's Canyon Deshay right there. And by studying this deposit across the modern landscape, we're able to determine where these seas, dunes, and mountains were located. And finally, for the White Rim Sandstone, we had an ocean coming down here from the west and begin to flood the western portions of the Grand Canyon, and all these dunes were located in the interior part of the continent right there. So looking at a global view of all the continents at this time, we see this was the time of the giant supercontinent of Pangaea. Pangaea is a Greek word that means all land, and you might be able to pick out the shape of South America here. This is Africa sitting up against the Appalachian Mountains, and there's little bits of England and Greenland and Scandinavia and bits of Siberia up here. You can see an ice cap down here on the southern continents. It's just in the nighttime right there. But notice that all the continents have come together, and when they drifted together, they formed the Appalachian Mountains. And as I'm going to show you in just a bit, it's right there where the mountains formed that these continents began to split apart. So I just want to take a break here with our survey and tell you how these wonderful maps were made. Ron Blakey came up with the idea for these maps about 20 years ago, and he decided that the maps that we all used when we were going to college weren't good enough to portray these ancient landscapes. So what Ron did is he locked himself in his office and he started to study all of these various papers that people had come up with. And if you've ever been in Ron's office, he just has stacks and stacks of professional papers that talk about the most arcane things, like the geology of the Pacific Ocean margins and the geology of Kazakhstan. And what he has done is he has collected and synthesized all of this information. This can be considered original research in itself, because what he does is he takes all the different papers that other geologists are writing about, and when he synthesizes it, then he puts it into a digital form on his computer, and you can see Ron working at his computer here, and he constructs these maps. Now think of all the different geologic time periods there are, and think of all the little bits of land and ocean there are on the earth. And he had to study that so that he would know where to put the oceans and where to put the mountains. So I'm going to show you how this works. When a geologist talks about a formation, they're not talking about something that looks like Snoopy rock, or it looks like a cannonball sitting on top there. A formation is a laterally continuous deposit of strata that can be followed for a long distance, and that one layer of strata represents a moment in time in Earth history. So let's just say that somebody in the room here was doing a study in Arizona and was studying this one layer at that particular point on the modern landscape. And then somebody else, unbeknownst to researcher number one, is studying it right there at Durango, Colorado. And somebody is up there near Meeker, Colorado, studying the same layer. And none of these geologists are talking to one another yet. They're just going out into the field, they're making a geologic map, and they're making interpretations for the environment in which these deposits originated. And they could say anything. They could say desert dunes or tidal flats or alluvial fans. And you can see here that there's 8 different studies that have happened. Well, what Ron Blakey does is he will take those 8 studies, he'll read all the papers, and he'll notice a pattern. And he might notice that all of a sudden now these 3 interpretations were similar, these 3 were similar, and these 2 were similar. And the interpretations might be that that was a river deposit, and the ones in the middle were a lake deposit, and the ones up there in Wyoming and northern Colorado were deposited in dunes. Then all you have to do, once you synthesize all that information, is you just go back and you make a beautiful map that people will enjoy looking at. So here you see the rivers right here. These are the lakes, and these are the sand dunes going off in this direction right here. So you might also be thinking, how does he actually construct the maps? Well, the first thing you do is you start with a blank canvas, and you put the state and county lines on there. If the state and county lines were not on there, you wouldn't know where the ancient landscape was located. So you have to have some modern reference. And the first thing that Ron does is, this is in a program called Photoshop. He gets a blue color with his cursor, and he starts to color in where the geologic evidence says there was an ocean. And in these maps, the darker the blue, the more evidence for deeper water. And the shallower the water, the lighter the blue is. So the ocean colors are added first. And then Ron adds the land elements. And these brown areas are meant to represent lowlands that had dry rivers on them. And these are meant to represent sandy dune environments. And on the Colorado Plateau, for some time periods, we have lots of sandy dunes across the landscape. And I'll draw your attention right here to where the ancestral Rockies are going to go. Sure enough, he puts those mountain ranges on there. And it looks realistic, doesn't it? It looks like a modern mountain range. And the reason for that is because it is a modern mountain range. Ron takes digital space photographs of the Himalayas or the Andes or Indonesia. He'll go to that modern mountain range, and however it formed, he will use that particular mountain range, and he'll paste it on the ancestral map like that. He's also done the same thing for the sand dunes. He has taken space photographs of dunes in the Gobi Desert and the Sahara Desert, and those are pasted on there to give them this realistic look. Now, some more professional geologists would have hoped that we would have put the formation names on top of the map, and you can see that for this one time period, there's about 7 or 8 different formation names. But we determined when we did the book that it might be better to not have the formation names there, because the formation names kind of take away from the artistic quality of the maps. And when you look through the book, you're going to see that it's a very artistic way to portray these ancient landscapes. We thought for a while that maybe we'd have plastic sheets that you could fold over the maps with the formation names there. But when you mention plastic sheets inserted to a book publisher, you can see their blood pressure rise immediately, because inserting plastic sheets is not only costly, but it's very, very bothersome to try to get that plastic in there. So just continuing with our survey now, we move on up to the age of dinosaurs. I was lucky enough to fly over the Canyonlands area working with a Discovery Channel film crew on a very clear day, and I got lots of pictures of the Canyonlands area, a time period known as the Triassic. And in this global view here, you might be able to pick out these very long linear lakes that are beginning to develop right on the crest of the Appalachian Mountains. And this is the initial pull apart of Pangea. As the heat beneath the supercontinent began to collect, it started to drive these two continents apart and create these rift valleys. And there's a couple of Civil War battlefields back east that were fought on the lavas that erupted out as these rifting events happened here. The Battle of Bull Run is one of them. There's a whole field of Civil War geology that you can attend meetings for at these professional conferences. One of the first formations is the Moenkopi Formation, about 240 million years old. And what you're going to see in the next few series of maps is a river system developed across the southwest that went from the southeast to the northwest. One of the most colorful units on the plateau is the Chinle Formation. This represents the time period when dinosaurs first appear in the rock record. In North America, that's about 225 million years ago. And here's this Chinle Formation. There actually is a member in the Chinle called the Shinnerup conglomerate. And both Ron and I believe that these are great big trunk river systems, maybe on the scale of the Amazon River today, where these giant rivers were coursing across the southwestern part of North America. It is true that when you find one petrified log, you find dozens of them because these were accumulating in log jams on these great big river systems. And just a few million years later, the climate got very humid, and those river systems turned into very shallow lakes during the petrified forest member about 215 million years ago. You can still see the rivers going in the same direction, but notice that on these maps there is also information about the climate. When you see a map that is greener in color, that is the interpretation based on the fossils and the sediments that this was a more humid time in Earth history. So this is a humid time right here, but we just go to a time period now known as the Jurassic. Thank you, Michael Crichton and Steven Spielberg, for popularizing that name for all of us. We never have to tell anybody about the Jurassic, they know about it. But here in the Castle Valley along the Colorado River near Moab are some fantastic Jurassic Age sandstones that record a time when it was very arid on the Colorado Plateau. And here's a feature called Castle Tower in Castle Valley, and it's cut out of the Wingate Sandstone. And then this particular picture of Navajo Sandstone in the Vermilion Cliffs. These crossbeds here actually record the direction of dune migration, and thus they record the ancient wind direction. Whichever way those beds dip is the direction that the dune was migrating, and we postulate that's the direction that the wind was blowing. So for about 205 million years, we had the Wingate Sandstone being deposited on the eastern Colorado Plateau, and there was a more river deposit that was present in Arizona, and that's known as the Moenkopi Formation. So there were two different formations being deposited at the same time, and that's very confusing to geology students when you're driving across the Colorado Plateau and they're trying to find the Wingate Sandstone, and you tell them, well, in this part of the plateau, it's actually the Moenkopi Formation. This river system is descended from those Chinle river systems. You can see it's headed in the same direction, but notice that it has a distributary channel form right there. And as the climate got drier during the Jurassic, this river system began to dry up in a pan right there. And the geologic evidence indicates that during the Jurassic, the climate was getting drier. And if you recognize this feature right here, this is actually the Okavango Delta in the country of Botswana today. And Ron has used that as a modern analog for what the Moenkopi depositional environment was 205 million years ago. So I don't expect anybody to recognize the Okavango Delta, but that's exactly what that is right there. And you're going to see this increase in aridity. Look at what happens during the Kayenta Formation. The dunes start to expand. They blow across this river system and they create very small lakes on the landscape. And then finally, by about 190 million years ago, we have the largest expanse of fossil sand probably on planet Earth. This is the great Navajo Sandstone. And you can see the extent of it, pretty much covering all of the Colorado Plateau. There's even been outcrops of it found in the Mojave Desert in eastern California, and some very spectacular outcrops, although they're very subtle, down near Tucson, Arizona, where the sand dunes were blowing up against the lower flanks of these explosive volcanoes. You can see these volcanoes that Ron has put right here. And of course, these volcanoes are very, very important to the study of geology, because when a huge ash would come out of the volcano, it could become interbedded in the dune field, and the ash beds are actually what the geologists can date. The volcanic ash contains a record of the exact moment in time when that stratum was laid down. The Carmel Formation are these very crinkly beds that are found at the base of the Arches in Arches National Park, and they're overlain by the Entrada Sandstone, and this combination of Carmel Formation below and Entrada above is what's responsible for the arches forming there. Some of you may have hiked to Delicate Arch, that's also in the Entrada Sandstone, and this is all part of a depositional system that was happening on the shoreline of what we call the Sundance Sea formation that was named up in Wyoming, but this sea would sometimes expand down into Arizona and then it would retreat back up. And the Entrada Sandstone are these dune fields that were blowing on the eastern shoreline of this shallow ocean basin right there. By the way, it's at this time right here that the very last of the ancestral Rockies was buried by this sandstone. And if you ever go to Black Canyon of the Gunnison National Park and you drive around on their rim roads, you can see the very old Vishnu Schist, and sitting on top of the Vishnu Schist is the Entrada Sandstone, and that's the information that we use to determine that the ancestral Rockies were finally eroded flat by about 160 or 165 million years ago. The Morrison Formation is the great dinosaur graveyard on the plateau, and there are quite a few dinosaur fossils that have been found in the Morrison, and this is the environment of deposition for that. We had huge mountains down in southern Arizona, and the rivers were coming out of those mountains and going across the plateau towards the northeast. And occasionally there would be lakes present on this landscape, and those lakes are a lot of times where these dinosaurs would walk around the fringes of and get caught up in there. And lastly, for the age of dinosaurs is the Cretaceous time period. If you've ever been to the eastern side of Capitol Reef National Park, you've seen this outcrop right here near Hanksville. These are the deposits of the Mancos Shale or the Tropic Shale, and they are the deposits of a shallow inland seaway that used to exist here. Look at the extent of this seaway at about 92 million years ago. This is North America right here, and it's been divided into 3 different pieces of land because there was no ice on planet Earth at this time, and all that water had run back and flooded the lowest parts of the continent. You can even see parts of Africa that are flooded. Europe is highly flooded right here with just a few emergent pieces of land. And notice that Africa and North America have moved apart. This is about 105 million years ago when the ocean is just starting to flood the interior of the plateau. And by 92 million years ago, we had half of the Grand Canyon region covered in ocean water. Now, this was the last time that the plateau would be inundated by seawater. It has been inundated by seawater many, many times in the past. This is the very last time that this is going to happen. And by the time that the Mesa Verde group was deposited, you can see that shoreline retreating there. And it's interesting to note that on the beaches of this ancient sea right here, there was a golden sandstone that was deposited on the beaches. And about 80 million years after this, groups of Anasazi Indians were using alcoves in that sandstone to build their cliff dwellings on Mesa Verde. And don't know if those guys ever knew that the geology was what was controlling their alcoves. They probably didn't. And that's one of the reasons I'm glad that I live in the time period I do, to know this ancient geography. Right at the time that the dinosaurs went extinct, the seaway had completely disappeared from the plateau, and we're going to start creating the modern landscape at this time. But one of the interesting things to note is that when this initial river system was imprinted on the landscape, there were no Rocky Mountains at this time, and these rivers went from southwest to northeast across the Colorado Plateau. And if you think of the Colorado River today, it starts up here and flows to the southwest in this direction now. So just in 65 million years, we're going to have to reverse these drainages and make them go the other way. And that's a very interesting story that I talked about in my book, Carving Grand Canyon. This all happened right when the dinosaurs went extinct, and it was also at this time that the plateau began to be uplifted. This is the creation of the Rocky Mountains, and when the plateau was put into a position where it could be eroded. Just to the southeast of Salt Lake City, there was a deposit known as the Wasatch Formation. This photograph is from Desolation Canyon, and these particular strata were deposited in large freshwater lakes that existed between about 50 and 55 and 40 million years ago. And you can see the outlines of some of these big freshwater lakes. These are the lakes that the oil shale is deposited in. And in these freshwater lakes, there were lots of small plankton that were living, critters that lived in the water column, and as they went down to the lake bottom, they became buried and cooked into the tar shale deposits. Also, the colorful hoodoos at Bryce were deposited in that area right there. And then about 30 to 20 million years ago, we had these volcanic intrusions invade the crust of the Colorado Plateau. These are giant mushroom-shaped intrusions of magma. Their cover of sedimentary rock has been stripped off the top already, and the inner cores of these intrusions are now exposed in places like the Henry Mountains, the Abajo Mountains, and the La Salle Mountains near Moab. Navajo Mountain is thought to be as well a laccolith, which is what we call these, but it still has its sedimentary cover on it, so we don't know for sure. And here's a map from about 30 million years ago, and you can see the La Salle Mountain intrusion here, and the Abajos, the Henry Mountains. There was a giant volcanic field called the Marysvale Volcanics, and if you've ever been to the San Juan Mountains near Silverton and Ouray, this was the time when all that volcanic rock was erupted, and all the gold and silver was put into the crust at exactly this time during this volcanic period. And a researcher down in New Mexico has recently determined that maybe there was a giant dune field that was present just at the foot of the San Juan Mountains, and that this dune field could have stretched for a couple hundred of miles across Arizona and New Mexico at this time. Amazing to think that only in the last 6 million years have our canyons been cut. Of course, canyons are what everybody associates the Colorado Plateau with, and yet these canyons were probably not there prior to 6 million years ago. And that's the date that they give you for the Grand Canyon. So between 5.5 and 6 million years ago is when the Colorado River became integrated, and this particular map just shows one theory on how that could have happened, and that is by a series of lakes that could have been spilling down and filling, and then once it got to its lowest rim, it would spill into the next lake and just go as a chain of lakes all the way down to the newly opened Gulf of California. And the San Andreas Fault has played a huge role in the carving of the Colorado Plateau canyons, because when the San Andreas Fault ripped open the Gulf of California, it lowered this part of the earth, leaving the plateau as a high arid plateau, and the rivers chiseled their way down into that landscape. And what chiseling they have done. We live in one of the most beautiful places on the planet, as long as you don't mind a landscape that has very little rainfall on it. That's probably the one thing we don't have. But this is a fantastically sculpted landscape. And thinking about all the maps that you have seen tonight, this is the one map that you and I get to live with our whole lives. Everything that we have determined about the past is the result of studying rocks on this landscape right here. And although geology can be a great way to tear your ego apart because it makes you feel so small, you can take some comfort in knowing that we are the first generation of people to really ever see the earth in this way. Just when I was studying geology in the 1970s and 80s, we never had these clear views. We had pen and ink drawings of the ancient continents and the rivers and things like that, but it didn't inspire you the way that these maps do. And one of the things I've noticed from my students is that they can very easily grasp difficult geologic concepts of things changing through time just by looking at the maps and perusing the information that's contained on them. You know, Ron has also taken a look into the future, and based on the rate that continents are moving and the direction they're moving, he's made this projection for about 100 million years from now. And one of the big things you see here is that Australia has drifted much farther to the north. This is where Australia sits today, but Australia has drifted and crashed into China right there. And I always tell my students that if they want to become immortal, one of the things they can do is write in their will that they want to be buried at the Great Barrier Reef in Australia. And then one day, 100 million years from now, when Australia crashes into China, your bones as a fossil will be uplifted onto a ledge in a Himalayan-like mountain range, that is bound to form right there. And you can see that Himalayan range right there. Look at that, the East African rift here is completely opened up, and Indian Ocean water has completely flooded around what we call the Somali Plate. So those of you that have been to safari in Eastern Africa, if you do a safari in the future, you're going to have to get on a boat and you'll be looking for whales and dolphins. And just think of the coastline that the Somali pirates will have to course around right in there. You can see that just in this projection, Ron made an assumption. He made an assumption that maybe it would be warmer at exactly this moment in time. So you can see the Antarctic ice sheet is not nearly as big. And so the water that was tied up as ice on Antarctica has flooded all the low-level river basins like the Amazon right here and the Mississippi there. And you can see how big Hudson Bay is. You notice also that Baja California has split off from mainland North America there. And it puts Los Angeles right next to San Francisco, and the Dodgers and Giants are crosstown rivals once again because of geology. Well, before we finish tonight, I just want to leave you with a beautiful view of our home continent of North America through time. And for this particular set of slides, I'm going to keep North America stationary. That red dot will stay right there. Nebraska will stay right there. And we'll move everything else around North America. And I'll call out the millions of years to you down here in the corner. Don't look at that at all. Just watch how everything changes around North America. And remember that earth tones represent arid climates and green tones represent more humid climates. And we go from 510 million years ago to 340. You can see Africa approaching from the southeast. And then, bam, Africa hits at 312 and helps to create the Appalachian Mountains. 272 million, very arid on the Colorado Plateau at this time. 240, you can see those southeast rivers that have formed during Moenkopi and Chinle time. 215 million, 180, 160, here comes the Sundance Sea. And at 150 million years ago, it's now retreating back. Notice all the islands starting to come in here to Oregon and Washington. That's going to become part of those states as that material collides with North America. 105, 92, 82, 60 million years ago, 50 million years ago, 30 million, 15, 3, and 1 million years ago during the Ice Age when ice covered 1/3 of North America. As recently as just 10,000 years ago as well. So that's a beautiful view of our continent through time, a beautiful view of the Colorado Plateau through time. I invite all of you, if you're interested, to pick up a copy of the book and just leave it on your coffee table at home and watch what people do when they stroll across that book and they see what our home continent used to look like. You know, this Colorado Plateau is a very special place, and I thank all of you for coming out tonight to listen to this story. You know, it's nice to study geology just from an intellectual point of view, but actually studying all this climate change and seeing how long it took for this landscape to come to be, there really are true lessons from the past that we can learn. And I know that not all of you will be able to study geology in a deep way that some of us have here in this room, but if you just expose yourself just a tiny bit to the long span of time that this landscape has been in creation, it will give you a much greater appreciation. Anytime you travel away from Salt Lake City, you will have this appreciation for the landscape and for our earth. Thank you all very, very much.